A very good evening to all the dear students. Very good evening. How are you? I hope you are doing well. You had your lunch, breakfast, everything is done. Good evening, Janu. Good evening, Reddy, Raghav. Anil, good evening. Alia, Jeannie, good evening. Sri, namaste. Nandu, good evening. Good evening, Dandelion, Reshma, hi. Karthik, good evening. Pinky Esari, good evening. Sanjay, Arvind, yes, very good evening to all the dear students. Rohit, Chaitanya, Priya, yes. So, are you all ready to start a new chapter today? A very interesting inorganic chemistry chapter. Are you all ready to start? One chapter of physical chemistry we already discussed. Bharti, Anita, Vardhan. Are you all ready to start a new chapter? Good evening. Yes. So the new chapter that will start today is going to be chemical bonding. Okay, not the whole chapter. Chemical bonding is a huge chapter. Okay, chemical bonding is the biggest chapter of class 11th as well as class 12th together. Most questions in NEET, if they come from any one chapter, this chapter is chemical bonding. How the bonds are formed, how the molecules look like. So I'll be giving you so many tricks to draw structures. Okay, so let us start with our today's topic, which is going to be chemical bonding and molecular structure. Chemical bonding and molecular structure. So today, in today's class or in next 3 or 4 classes, I'll be dealing with how do you draw structures of a given molecule. If a molecule is given to you like CO2, if an ion is given to you like NO2 minus, NO3 minus, then how do you draw their structures? Okay, some tricks I'll be discussing. So 3 tricks I will discuss with you. First part will be to draw structure using Lewis dot structure theory. So drawing Lewis dot structures. Second, after you have learnt about Lewis dot structure, there are some problems with Lewis dot structures. Okay, we'll be writing in the drawbacks that Lewis dot structures do not give us the clear picture of how a molecule looks like and behaves. So next we'll go for drawing the structure using hybridization. Drawing structures using hybridization and VSEPR theory. Okay, so these are the 2 things that I'm going to teach you. These are 2 things that I'm going to teach you. Drawing the Lewis dot structures today we'll do. Drawing structure using hybridization and VSEPR theory in the next 3 classes it will continue. 2 classes. Next 2 classes that will continue. Okay, so next 3 classes schedule I've given you. This is going to be today's class. This is 28th March or April, sorry. 28th April, this will go on. 29th, 30th April, this will go on. Okay, so this is going to be our plan. We'll practice drawing many Lewis dot structures in today's class. You practice many from your home. I'll give you some homework. And then tomorrow I'll be telling you more detailed structure of a particular molecule. Okay, let us start, everybody. So we'll be starting with how to draw Lewis dot structures. how to draw Lewis dot structure. See, we'll not be using the concept that books tell us. Books tell us to draw, write the formula. Beta, Joy Ravi Konda, please, control yourself. Okay, Joy Ravi Kondi Pudi. I will not explain, sorry. Let us study this, okay? So, how to draw the Lewis dot structure, will not be using the bookish way, okay? How the books tell you to draw them by imagination. So, books tell you to draw the Lewis dot structures by imagination, which you would have done in your class 9th and 10th as well, okay? All of you have drawn some Lewis dot structure, yes or no? For ammonia, for water, for CH4, all of you have seen how to draw, yes or no? Have you all done this before? It is simplified drawing of how valence electrons are arranged around the atom in a molecule. Yes, that is correct. That is correct. Yes. Today we'll be dealing with a trick way to do it. So I'll tell you the trick directly and then we'll start with the formula. So trick, we'll call it as TVSU trick. We'll call the trick as TVSU trick. TVSU trick. All of you can start writing. All of you can start writing. Here you will not be imagining anything. You will not imagine that carbon is having 4 valence electron, oxygen is having 6 and they are trying to share with each other. We will not be dealing with that. We'll directly go by a trick method or a very fast method to make any structure. TVSU trick. Here T represents total electrons to complete octets. So T means total. T means total. V means valence electrons. V means valence electrons. S means shared electrons. So when you write T and V, when you do T minus V, you will reach to S. S means shared electrons. Shared electrons. The value of S will be the first number minus second number, T minus V. And we will represent shared electrons as dots. We will represent shared electrons as dots. First write it down, then you will understand. TVSU. U means unshared electrons. U means unshared electrons. And when you do second minus third number, you will get U. So U is V minus S. And you will represent unshared electrons by X. Okay. Just as a habit, we will represent unshared electron by X. So when you have 2 unshared electrons, you will show 2 X's. When you have a paired electron, you will show with the help of dots. TVSU. First remember this. Now what is T? T means total electrons required to complete all octets. So when you have a molecule, in every molecule, each atom tries to have 8 electrons around it. Each atom tries to have 8 electrons around it. If it is a hydrogen atom, it tries to have 2 electrons around it. That is what Lewis told you. We call it as Lewis octet rule. Okay, we call it as Lewis octet rule. So to complete its octet, everyone is trying to make bonds, is what Lewis told you. So first we'll write Lewis octet rule, then we'll see this trick further. Okay, so we'll mention Lewis octet rule. So people were thinking that why does bonding take place? Why does bonding take place? And they saw that everybody is trying to make bonds. Hydrogen is trying to make bonds. Chlorine is trying to make bonds. Oxygen is never found in the free state. It is also trying to make bonds. But only one person who is very stable is not making any bonds were noble gases or inert gases. Helium, neon, argon, krypton. They were not making bonds at that point of time. Nowadays, xenon has made some compounds, but that point of time, no noble gas compounds were known. So everybody thought that noble gases are the most stable people. Everyone wants to become a noble gas. Now, how can someone become a noble gas? What is so special about noble gas? So special about noble gas is always they have 8 electrons in their outermost shell, except helium. So when you look at helium, helium electronic configuration is 2. When you look at neon, neon's electronic configuration is 2,8. All of you would have studied that. Neon is 2,8. Argon is 2,8,8. Okay, like that krypton is 2,8,18,8, like this. So it was seen that final valence shell of almost every noble gas had 8 electrons. Then Lewis thought that everybody wants to become noble gas. They also want 8 electrons in their outermost shell to become stable. That's why they try to either lose some electron, or they gain some electron, or they share some electron to get octet configuration. Okay, that is called as Lewis octet rule. So let us write it down. Lewis octet rule, which says that in order to gain stability, atoms either gain or lose or share their valence electrons in order to gain stability. Atoms either gain, lose or share their valence electron in order to obtain in order to obtain 8 electrons in their valence shell. With bracket we call it octet configuration. Just like noble gases. Okay, we will not follow this octet rule for hydrogen. There is one exception, that is hydrogen, that will try to mimic helium, because hydrogen's nearest noble gas is helium and hydrogen cannot have more than 2 electrons. So hydrogen will try to get a duplet, other people will try to get a octet. Okay, hydrogen is the exception here. Hydrogen follows, so I can write here as an exception. Hydrogen follows duplet rule instead of octet rule. Hydrogen follows duplet rule. So hydrogen wants to become like helium, other people want to become other noble gases. Like chlorine will want to become argon because chlorine is very near to argon. Nitrogen would want to become neon because nitrogen is very near to neon in the periodic table. Okay. Now we'll see what is T. Remember everybody, T means total electrons required to complete the octet. So how to find the T? T is nothing but how many atoms are there inside that molecule multiplied by 8. So T is 8 times number of atoms. If there is a hydrogen, then you do 2 times number of hydrogens. 2 times number of hydrogens. Okay, I'll show you the example. So you will ask to a molecule, when you see a molecule next to you, you will ask to that molecule, how many electrons do you want to become stable? He will say, if let's say molecule is H2O, hydrogen say, I to want 2 electron to become stable, but oxygen say, I want 8. Okay, so hydrogen will always try to complete a duplet, and oxygen will always try to complete a octet. Other people will always try to complete an octet. So what is T? 8 times atoms plus 2 times hydrogen. Done. Once you can find TVSU, then you can easily draw the structure. Let us try the first one. Okay, example 1. All of you can write here. Example number 1. Example number 1. Let us take the example of carbon dioxide, CO2. Okay, carbon dioxide, CO2. First example I will take carbon dioxide. After this second example I will take is going to be containing hydrogen, which will be CH4. Then I will take example number 3, which is going to be NH3. Then I will take example number 4. Okay, first let us draw only 3 examples on this page, then we'll go for the next ones. Then we'll go for little difficult ones also, like carbonate, nitrate, nitrite, all those also you can draw. So what we have to do? As soon as you look at the molecule, write TVSU. TVSU. Okay, TVSU. T means you will talk to the molecule and ask how many total electrons you need so that all your octets are complete. Carbon says, so there are 3 atoms. 3 people will say I need 8, 8, 8, which is 24. So total electrons are 3 atoms multiplied by 8. No hydrogen is there, so nothing to be multiplied by 2. So T is 24. T value is 24. Just find the TVSU. Next is V, valence electron. We know that carbon belongs to group 14. Carbon has 4 valence electrons. And each oxygen has 6 valence electrons. So 2 times 6. Okay. Carbon has 4 valence electron and oxygen has 6 valence electron. Now, all of you, I hope, remember that number of valence electrons are how many? So 4 plus 12, this is going to be 16. 16. So T is 24, V 16. What was S? I told you T minus V. So 24 minus 16 you do, which is going to be 8. So 8 dots will be required in this structure, 8 dots. And what is unshared electron? That was V minus S. V minus S, 16 minus 8, which is also 8. So 8 X's will be visible to us. Okay. So 8 dots, 8 X's. Now what to do? Keep the atom which is lesser in number in the middle. So here the center atom will be carbon and surrounding atom will be oxygen. Okay. Center atom will be carbon, surrounding atom will be oxygen, like this. First start giving the shared electrons, 8 shared electrons. 8 shared electrons you have to give, so you start giving. Always give pair by pair, that you two keep 1 pair, so 1 shared pair here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, all the shared electrons you have given now. After giving all the shared electrons, you ask the center atom and the surrounding atom that are you happy? Is your octet complete? If they say yes, our octet is complete, then you circle them. So don't give them any more electrons. If their octet is not complete, then you give them unshared electrons also. So 8 shared electrons were there. I have given like this. Carbon says I am so happy. Around carbon there are 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there around the carbon. So carbon says I am so happy, I don't need any more electron. Oxygens are still not happy because this oxygen has 4 around it, this oxygen has 4 around it. So I'll just circle the carbon. I'll say carbon says I don't want any more electrons, I am happy. Okay, so we'll say to carbon, okay, will not give you any unshared electron. Unshared will give to only oxygen. So 8 unshared. So I'll give it here. 1, 2, 3, 4. Till now nobody is happy. Till now oxygen is not happy. Oxygen has 6 around it. 1, 2, 3, 4, 5, 6. This oxygen says I am done. I don't need any more electron. So 1, 2, 3, 4, 5, 6, 6 I have given, 7, 8. This oxygen says I am done. I do not need any more electrons. So this is the Lewis octet structure, okay, Lewis dot structure, where I get carbon, oxygen, oxygen. 2 electrons shared means 1 bond. 4 electrons shared means double bond. So there is a double bond here. There is a double bond here. This oxygen carries 2 lone pair. 1 lone pair, 2 lone pair. This oxygen also carried 2 lone pair. 1 lone pair, 2 lone pair. This is the structure of carbon dioxide. So you don't have to imagine anything. Okay, we don't have to imagine anything. This is how we draw the structure. One is there, one I have told you. Let me tell you one more. Okay, then you try the next one. Ammonia, all of you see here, ammonia, NH3. Ammonia. First thing you write, TVSU quickly. Total, valence, shared, unshared, total. Nitrogen say I need 8. But 3 hydrogen says I need 2, 2, 2. So number of atoms apart from hydrogen is 1. That atom multiplied by 8. So 8 plus 3 times 2, which is 14. T is 14. T is 14. Valence. Ammonia 15th group has 5 valence electron. Each hydrogen has 1 valence electron. 5 plus 3, 8. Shared was T minus V, which was 14 minus 8, 6. 6 dots will be there in this structure. 6 dots. And unshared was V minus S. 8 minus 6, which is 2. 2 X's will be there in this structure. Okay, 2 unpaired electron and 6 paired electrons. Now let us draw. Keeping nitrogen in the middle, I am keeping hydrogens on the side. Anywhere you can keep, because anyways your Lewis rule cannot determine the exact structure, but just the bonds it can tell you. Where will be single bond, where will be double bond. Exact structure, bond angles will be told by hybridization and VSEPR only. Okay, so I have kept them like this. Then give shared electron. 6 shared electron. You take 1, 2, 1 shared pair. 1, 2, 3, 4, 5, 6. So one sharing I have given, 1 shared pair I have given to NH. 1 bond I have given to other NH. 1 bond I have given to another NH. I am asking who is happy. Hydrogen says we are happy. Hydrogen says I don't need anything else. My octet is complete only. My octet is complete only. I am happy. This hydrogen says I am also happy. This hydrogen says I am also happy. Nitrogen says I am still not happy because my octet is still not complete. I have 6 electrons around me. So we'll say, okay, the unshared electron will give only to nitrogen. There are 2 unshared electrons, so nitrogen takes that. And now nitrogen is also happy. Nitrogen also has 8 electrons around it. Can you see here? Nitrogen also has 8 electrons around it, which is 2 here, 2 here, 2 here, and 2 here. So total nitrogen has shared electron 6 around it and 2 unshared around it. So total 8. So nitrogen says I am also happy. So the structure becomes nitrogen, single, 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 3 single bonds hydrogen, and nitrogen is carrying 1 lone pair also. This is the structure. Good, simple. Is it clear to everyone? The first 2, yes or no? The first 2 are clear to everyone? The first 2 structures how I have drawn? Are the first 2 structures clear to everyone? Yes, okay. All right. Now let's do some difficult ones. Okay. One CH4 also will do. It's a direct one. TVSU. TVSU. Total. Carbon says I need 8. Each hydrogen say I need 2, 2, 2. So 8 plus 8, 16. 8 plus 8, 16. 8 plus 8, 16. 16 plus 8, 24. 24 plus 8, 26. 26 plus 8, 28. 28 plus 8, 29. 29 plus 8, 30. 30 plus 8, 31. 31 plus 8, 32. 32 plus 8, 33. 33 plus 8, 34. 34 plus 8, 35. 35 plus 8, 36. 36 plus 8, 37. 37 plus 8, 38. 38 plus 8, 39. 39 plus 8, 40. 40 plus 8, 41. 41 plus 8, 42. 42 plus 8, 43. 43 plus 8, 44. 44 plus 8, 45. 45 plus 8, 46. 46 plus 8, 47. 47 plus 8, 48. 48 plus 8, 49. 49 plus 8, 50. 50 plus 8, 51. 51 plus 8, 52. 52 plus 8, 53. 53 plus 8, 54. 54 plus 8, 55. 55 plus 8, 56. 56 plus 8, 57. 57 plus 8, 58. 58 plus 8, 59. 59 plus 8, 60. 60 plus correct? Carbon says I need 8. Arey beta, T is nothing but total electrons. Total electrons means, yes, okay. Valence electron, carbon belongs to 14th group, so 4 valence electron. Each hydrogen has 1 valence electron, so 8. Then S is 16 minus 8, T minus V, which is 8. So 8 dots, and U is 8 minus 8, which is going to be 0. So V minus S, which is going to be 0. So no X's will be there. That means no unshared electrons. So we'll draw it like carbon in the middle, 4 hydrogens on the side, then giving them 8 shared electrons. 1, 2, 3, 4, 5, 6, 7, 8. As soon as you have given, hydrogen says, I am happy, don't give me any more electron. This hydrogen says, I am also happy, don't give me any more electrons. This hydrogen says, I am also happy, don't give me any more electrons. And the top hydrogen says, I am also happy, don't give me any more electrons. So hydrogen is done. Carbon says, I am also happy, don't give me any more electrons. Carbon also has 8 around it. So this is the Lewis dot structure of methane, which is a carbon and 4 single bonded hydrogens, CH4. Okay. Yes. Next one. Now we'll do some ions. Okay. Now 3 examples of ions I'll give you. Some positively charged ions means cations, some negatively charged ions means anions. Some cations, some anions. Some cations, some anions. We'll do now. Okay. So let's do some more example. Example number 4. Example number 5. Example number 6. Let's do CO3 2 minus carbonate. Let's do NO3 minus nitrate. Let's do O3 ozone. Okay. Carbonate, nitrate, ozone. You can also try. If you have been doing it by your own method, you might feel difficulty now here. That's why I'm telling you the method that I told you just now. You can use that. It is going to make the life much simpler for you. Okay. Again, I'll just show you any one of them. Nitrate, let me show you, or carbonate, let me show you. TVSU. TVSU. Carbon says I need 8. Oxygen say I also need 8. So there are total 4 people. All of them are asking 8 electrons. 1 carbon, 3 oxygen. All 4 of them are saying we need 8 electrons. So total is 32. When you find total electron, don't look at any charge or anything. Just need to see how many atoms are there. Each atom will ask for 8 electrons. If there is a hydrogen, it will ask for 2 electrons. Okay. T will be taken same only for every molecule, for every cation, for every anion. Same way. Just ask them how many electrons do you need to complete octet. Once we have done that, when it is an anion, valence electrons will be taken little carefully. Valence electrons are how many? Carbon has 4 valence electron. Oxygen has 6, 6, 6. So 3 times 6 valence electron. And whenever you see any negative charge on the top, negative charge, add that many electrons. That means CO3 has taken 2 electrons extra to become CO3 2 minus. So 2 more because of the charge. Okay. 4 valence electron of the carbon, 18 of the oxygens, plus 2 extra on the top because of the charge. Okay. So how to find V? V means sum of valence electrons minus the charge. Sum of valence electron minus the charge. So sum of valence electrons is this, minus 2, because charge is negative. So I'll do minus the charge. Minus charge means minus of minus 2. So 2 electrons will add up. Okay, 2 electrons will add up. Whenever the charge is plus 2, then 2 electrons will subtract, means 2 electrons are removed from the valence shell. Okay, so this was the one. So V comes out to be 18 plus 4, 22 plus 2, 24. S was T minus V, which is 32 minus 24, 8. So 8 dots will come, and unshared electrons are V minus S, valence 24 and sharing 8, 24 minus 8, 16. 16 X's will come. Sri Devi, did you join the class on time, beta? T means, beta, total electrons required to complete. What is T? Simple, learn the formula. T means 8 times how many atoms are there. That is T. In carbonate, how many atoms are there? 4 atoms are there, na? So T means 8 times 4. 8 times 4, 32. That is T. Here T will be 8 times 4, 32. Here T will be 8 times 3, 24. So T is always 8 into atoms. V means valence electrons. To know the valence electrons, you should know the electronic configuration. I'll just mention those valence electrons. Atom and its valence electrons. All of you can see here. If atom is group 1 atom, group 1, there will be 1 valence electron, like hydrogen, like lithium. If atom is group 2 atom, there will be 2 valence electron, like beryllium, like magnesium. If atom belongs to group 13, then 3 valence electron. Group 13 means boron family. Boron, aluminium, gallium. First 2 you remember. If atom belongs to group 14, which is carbon, silicon, it will be 4 valence electrons. If atom belongs to group 15, which is going to be nitrogen family, nitrogen or phosphorus, then you will say valence electrons will be 5. When atom belongs to group 16, oxygen and sulfur, it will be 6. When atom belongs to group 17, which is halogens, 7 valence electron, and halogens and noble gas 8. So group 17, fluorine, chlorine, bromine, 7 valence electrons. And whenever it belongs to group 18, like neon, argon, then their valence electrons are 8. This is the value of V. Okay. Now just add the valence electrons, and if any negative charge is there, that much negative charge, that many electrons also you add. If any positive charge is there, that many electrons you subtract from the V. Okay. Is it clear now? Sri Devi, I explained it for you. Okay. So next one. So you can see here, T means 4 people, 8, 8, 8, 32. V means valence electron. Carbon belongs to 14th, carbon ka 4. 3 oxygens, 6, 6, 6. 4 plus 18, 22. I can see 2 negative charge here. So extra 2 electrons. Extra 2 electrons. Yes. Now 8 dots, 16 X's. Let's put carbon in the middle, oxygens on the sides. Carbon in the middle, oxygen on the sides. 8 sharing 1, 2, 3, 4, 5, 6. Okay. 2 more I have to give. Give anywhere. Either give to these 2 oxygen or these 2. Anywhere you can give. So 7, 8. After giving 8 sharing electrons, carbon says, "Bhai, I am so happy. Don't give me anything else." Total 8 electrons I had to keep in sharing. So I gave 2 here, 2 here, 2 here. After giving 6, 2 more I have to give. So I have given any one place. Carbon says, "I am so happy, don't give me any more electrons." Now give unpaired electron only to oxygen. Unshared electrons only will be given to oxygen. 16 are there now. So I'll give 2, 2 like this. You take 2, you take 2, you take 2. Anybody happy? Not happy. Oxygen says I am having only 6 around me. 4, 5, 6. 4 around it. 4 around. Not happy. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. 12 are given and this oxygen became happy. Says don't give me any more. I am happy only. Like this. So how many I have given out of 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All 16 are given. This oxygen also becomes happy. And this oxygen is also happy. So I have given the total shared and unshared electrons in such a way. So the structure becomes like this. Structure becomes like this. It is now carbon, double bond oxygen, single bond oxygen, single bond oxygen. Carbon, double bond oxygen, single bond oxygen, single bond oxygen. Now remember beta, whenever oxygen will be a single bonded oxygen, whenever oxygen will come single bonded oxygen, what should you do? Oxygen will always say, give me a minus charge. Give me a negative charge. If you have a negative charge, you give it. So oxygen is single bonded, says give me -1, you give it -1. Here also you give it -1. So whenever oxygen is a singly bonded atom in any molecule, whenever oxygen gets a one single bond, then oxygen will always get a charge. Oxygen will say give me -1. If you have negative charge, you give it. So I have given -1 to him, -1 to him. Okay. So I have given -1 to this oxygen. I have given -1 to this oxygen. If you do not have a negative charge, so if you have a negative charge, you give it. If you do not have a negative charge, then you give it a coordinate bond. What is coordinate bond? I'll explain in the later classes. You give it a dative bond. So oxygen single bonded will always ask for a -1. Oxygen single bonded will always ask for a -1. If you don't have a negative charge in the molecule, then you give it a coordinate bond. Yes, it is applicable only to oxygen. Okay, it is applicable only to oxygen. I am telling you trick right now. Okay, beta, it's not something that why we have to give -1 will be coming later, Raghav Reddy. You don't know what is complete chemical bonding right now. I'm not explaining the chapter here. Okay, one simple topic I have taken because it will be a very important topic. You will be asked to draw structures many times. So, in that case, I am just telling you what to do. So, next is nitrate. You see here nitrate, TVSU. TVSU. Total 4 people say we need 8 electrons. 32. T clear? Clear, sir. Valence electron. Nitrogen has 5 valence electrons. Each oxygen has 6 valence electrons. Nitrogen has 5 valence electron. Nitrogen belongs to group 15. Each oxygen has 6 and extra negative charge. So one more electron is added here. So total is 32. Valence electron become 5 plus 18, which is 23. 23 plus 1, 24. S means shared electron, which is first number minus second number in this trick, T minus V. 32 minus 24, 8. So 8 dots will be there. 8 dots will be there. U means unshared, which is V minus S. 24 minus 8, 16, X will be there. You might say, sir, same only na. This was also 8 and 16. It is also 8 and 16. So yes, structure will come same only here. Structure will come same only here. Bond will be little different. You can see here, bonding will be little different. Let's draw quickly. Nitrogen in the middle, oxygen on the sides. 8 sharing. 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen says, I am done. Don't give me any more electrons. Nitrogen ka octet is complete. So give unshared only to oxygen. Unshared electrons must be given only to oxygen. 1, 2, total 16 I am giving. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This oxygen is already complete, so I will not give him anything else. Oxygen is happy. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this becomes the Lewis dot structure, which is nitrogen, double bond oxygen, single bond oxygen, single bond oxygen. Now I told you, whenever oxygen is single bond, then it will ask for a negative charge. Oxygen says, give me minus. We say, okay, only one negative charge I have. So one of the oxygen, so I can give you -1. Other person, I can't give you -1. So oxygen says, okay, if you cannot give me -1, then give me coordinate bond. Then you give it coordinate bond. What is coordinate bond will come in the next class. So this bond is going to be a coordinate bond like this. This bond is going to be a coordinate bond like this. It is one of the important structure that you have to remember. Very important. All the structures that we are drawing today, no, kindly try to learn them only. Practice them 2, 3, 4 times and then you will be able to remember them also. Is the nitrate structure and carbonate structure clear to everybody? Please tell me. Is the nitrate and carbonate structure clear to everybody? Quickly tell me. Is it clear, yes or no? To Ram Babu it is clear, to Faiz it is clear to Shanmukh, it is clear, okay. Yes. Yug, watch the video once again, beta. Me explaining once again means whole class has to listen once again. Okay. So it is clear to 90% of you, that's a good thing. Others need to watch the video once again, okay. Others need to watch the video once again. Now I'll show you ozone. You can see ozone now, everybody. Now I'll show you ozone. Ozone is also a very important compound whose structure we should remember. TVSU. Ozone, you can also think of it as OO2. Okay, one oxygen in the middle, 2 on the sides. Find the TVSU quickly. T, 3 people all say we need 8, 8, 8, 24. Valence, all 3 oxygens have 6 valence electrons, 18. 24 minus 18, 6. 6 dots will come. 18 minus 6, 12. 12 X's will come. 12 unshared and 6 shared. Okay, start giving. Sharing में 6. 1, 2, 3, 4. 2 more I have to give. Give anywhere. This side or that side, your wish. 1, 2, 3, 4. I'll give this side. 5, 6. So oxygen says, I'm not happy yet. I don't have 8 electrons. I also don't have 8 electrons. I also don't have 8 electrons. So nobody is happy till now. Central oxygen has 6 around it. 1, 2, 3, 4, 5, 6. This side oxygen has 2 around it. This side oxygen has 4 around it. So we have to give unshared to everyone. You take 2. Out of 12, 2 given here. This oxygen says, I am happy. My octet is complete. Don't give me anything else. 1, 2, 3, 4, 5, 6, 7, 8. I am also happy. Don't give me anything. So my octet is complete. My octet is complete. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. My octet is also complete. Okay. This is how we have drawn the ozone. This oxygen's octet complete. This oxygen's octet complete. And central oxygen also octet complete. So what does the structure become? Structure become like this. O, single bond O, double bond O, central oxygen carrying a lone pair, side oxygens carrying 2 lone pair on this one, 3 lone pairs on this one. Oxygen is single bond. It says give me minus charge. We say I don't have minus charge. Okay, if you can't give me minus, give me coordinate bond. So this is a coordinate bond. Like this. Okay. So this is the one. Today I have explained you how to draw Lewis dot structure. In the next class, I will be explaining you how to draw structure more perfectly using hybridization and VSEPR theory. So today only I have told you how to draw the structure. I have not still not told you what is the shape, bent shape, tetrahedral shape, pyramidal shape. But in the next class we'll be dealing more in depth. Is this clear to everyone? Yes or no? Ozone clear? Ozone clear? For your homework, please try to draw these. Tomorrow also I will be taking some time for Lewis dot structures only. Draw ClO4 minus, draw PO4 3 minus, draw SO3, draw SO2, draw SO4 2 minus, draw NO2 positive, draw BF4 negative, and draw NH4 positive, and draw NO2 negative. These are your homework. Okay, practice them. You will feel more easy. Yes, good. Thank you. Bye-bye. Let it be on. Wait. Write down these homework. Practice them.